The world's industrial ecosystem relies on metals that most people barely think about. And among them, silver is perhaps the most critical and most overlooked. It is embedded invisibly in the circuits of smartphones, electric vehicles, solar panels, and advanced industrial machinery, yet it remains largely invisible to public discourse, treated as a commodity for speculation rather than a vital industrial necessity. Tesla, Apple, and countless other manufacturers assume continuous access to silver as a given, but that assumption is fragile and increasingly dangerous. China dominates the global refining of silver. Raw silver can be mined in many countries, but transforming it into high purity, high conductivity silver suitable for modern applications is concentrated almost entirely in Chinese facilities. This concentration gives China a silent but absolute leverage over the industries that rely on silver. Even a minor disruption in supply can cascade across global production lines. TOPCon solar cells, which are critical for next-generation solar efficiency, rely on silver for their conductive layers. There is no substitute that can match both conductivity and durability at scale. The solar industry, which is essential for the green revolution and global energy transition, is therefore highly vulnerable to supply shocks. A similar dependency exists for Tesla's EVs. Silver is required in multiple high conductivity contacts within batteries, inverters, and motor controllers. Without it, production lines stall, deliveries are delayed, costs rise, and companies face painful trade-offs between capacity, safety, and timelines. What makes silver scarcity so insidious is that it is largely invisible. Unlike oil shortages or electricity blackouts, silver shortages manifest quietly. Delayed projects, idle machinery, cost overruns, and reduced yields. Paper markets, including COMEX contracts and futures, obscure this scarcity by offering a false sense of abundance. When industrial buyers attempt to secure physical metal, premiums spike, liquidity vanishes, and operational plans are disrupted. The risk is shifting from financial to operational, from speculative to existential for companies that rely on continuous production. The consequences extend far beyond Tesla or Apple. They ripple across the U.S. solar industry, affecting renewable energy adoption, grid modernization, and even national energy security. This dependency exposes a systemic fragility that is rarely acknowledged in public policy or investment narratives, where technology is treated as abstract innovation divorced from the material realities that make it function. Historical precedents show that technological ambition without material alignment is vulnerable. Rare earth metals, oil crises, and uranium supply disruptions have all demonstrated that control over critical inputs defines industrial and geopolitical power. Ingenuity alone cannot overcome material scarcity. Factories and laboratories that once assumed silver access are now confronted with harsh operational realities. Engineers must redesign circuits, optimize processes to minimize silver usage, and in some cases, delay or cancel projects. Investment flows are redirected from innovation toward securing supply chains, building private stockpiles, and lobbying for political support. Financial markets often react only after operational stress appears. The disconnect between paper pricing and physical availability creates volatility, uncertainty, and mistrust. Governments and policy frameworks struggle to adapt because they operate on outdated assumptions of free and abundant trade. They underestimate the strategic concentration of refining capacity in China. Sovereign funds and industrial conglomerates quietly accumulate physical silver, creating secondary markets outside public exchanges. This decoupling of paper and physical pricing further increases volatility. Silent accumulation becomes a strategic tool, ensuring continuity of operations while influencing global price signals. The public sees only higher costs, slower product launches, and incremental delays. None of these symptoms are immediately attributable to the underlying material bottleneck. Over time, scarcity shapes culture, corporate strategy, and expectations. Engineers trained under these constraints internalize scarcity as default. Innovation shifts from breakthrough experimentation to optimization. Research priorities move toward feasible incremental improvements rather than radical technologies. Industrial hierarchies concentrate around regions and institutions with secured access to silver, creating long-term structural advantages. Western nations that outsourced refining decades ago now face structural disadvantages. Higher costs, slower timelines, and constant negotiation for supply reduce competitiveness. Industrial dependence becomes permanent, shaping both current production and the trajectory of future technological development. Every electron transmitted, every solar watt generated, every electric vehicle powered traces back to decades-old decisions about supply, refining, and access. The siege of silver is ongoing, silent, and absolute. It is not caused by technological failure, policy oversight, or financial mismanagement alone. It arises from the misalignment between ambition and material dependency. Tesla and Apple are visible examples, but the underlying risk touches countless industries. Supply bottlenecks, pricing volatility, and operational delays are systemic, predictable, and structural outcomes of concentrated refining control. Industrial decision makers are forced to operate under scarcity as the default. Every new design must account for limited material access, recycling efficiency, and alternative sourcing strategies. Talent and knowledge migrate to secure supply corridors. Innovation follows access, not imagination. Nations controlling refined silver gain disproportionate influence over global industry. History shows that reliance on concentrated critical resources shapes long-term geopolitical and industrial outcomes. In the 21st century, silver is one such resource. The industrial siege shapes production, innovation, strategy, and power. Every decision, delay, and optimization reflects the hidden governance of an unassuming yet essential metal. The future will be written not by ideas alone, but by access, control, and strategic management of scarcity. Tesla's EV lines, Apple's electronics, solar panel deployment, and grid modernization projects all converge on the same vulnerability. Supply shocks propagate silently, but leave visible consequences. Industrial planning now revolves around risk management, not ambition alone. Innovation bends around scarcity. Strategic foresight becomes survival. Talent, infrastructure, and capital cluster where materials flow freely, leaving lagging regions perpetually behind. Silver scarcity teaches that technological ambition divorced from material supply is fragile. Every idle line, every delayed launch, every missed target is a symptom of this invisible bottleneck. The narrative of abundant innovation masks the invisible siege, yet the siege dictates the pace of progress, reshapes corporate culture, and concentrates power geographically. Factories optimize for survival. Engineers design around limitations, markets decouple paper from physical reality, and governments scramble to respond after the fact. The electrification of society and the green transition are subtly constrained by a single metal. The consequences are systemic, long-lasting, and strategically absolute. Industrial dependence becomes structural. Financial markets struggle to reflect operational risk. Innovation is redirected from aspiration to survival. Silver is more than a commodity. It is a strategic axis around which the modern industrial world rotates. Factories, lines, and entire industries now operate according to the availability of a small, invisible metal. Control over silver determines timelines, costs, and capacity. Without it, even the most ambitious technological visions are at risk. This crisis highlights the fragility of supply chains, the limitations of policy frameworks, and the invisible levers of industrial power. Tesla, Apple, and the solar industry exemplify the challenge. Supply bottlenecks, pricing volatility, and operational delays are systemic. Industrial planning, investment, and innovation must now prioritize scarcity. Engineers design within constraints, talent migrates to secure supply chains, and nations with access to refined silver gain decisive advantage. The future is not written by ideas alone. It is written by access, control, and scarcity management. Silver quietly governs the pace of modern industry, and the consequences of its concentration are profound, invisible, and lasting. Every production line, every solar project, and every EV launch bears the mark of this metal. The industrial siege continues, shaping the fate of technology, industry, and national power in ways that are largely unseen but absolutely decisive. The industrial world is built on assumptions, and one of the most dangerous assumptions is that critical materials will always be available. Silver is at the heart of this fragile illusion. Every solar cell, every electric vehicle, every high-efficiency circuit depends on its unique properties. Its conductivity, its stability, its unmatched performance make it irreplaceable. Yet, despite this crucial role, the world remains blind to the silent siege that governs its supply. China controls more than 80% of refined silver production, creating a choke point that few governments or industries fully understand. Mining alone is insufficient. Raw silver requires highly specialized refining to meet industrial standards. Without this processing, it cannot be used in electronics, photovoltaics, or EV components. The reality is that Tesla, Apple, and leading solar manufacturers rely on Chinese refiners not by choice, but by necessity. Every delay in refining reverberates across the globe. Factories wait for shipments that may never arrive on time. Production lines halt, and ambitious projects are postponed. The Green Revolution, hailed as a path to energy independence and sustainability, is quietly constrained by a small, invisible metal. This is not speculation. It is a tangible operational crisis, unfolding silently while the public remains unaware. TOPCon solar cells, which represent the cutting edge of solar efficiency, are chemically dependent on silver. No other element can replicate its properties at scale. Without a continuous supply, solar installation projects are delayed, energy targets are missed, and governments are forced to revise plans for renewable energy expansion. This scarcity has geopolitical implications. Countries that rely on imported refined silver are vulnerable not only economically, but strategically. Tesla's electric vehicles face a similar predicament. Silver is embedded in every high conductivity contact within batteries, inverters, and motors. A shortage disrupts the entire production cycle. Manufacturing becomes unpredictable. Delivery timelines slip, costs rise. And yet, these constraints remain invisible to investors and the public, hidden behind stock market pricing and corporate statements. Paper markets, including futures contracts and COMEX trading, create the illusion of abundance. They obscure the true scarcity by providing access to paper silver that cannot fulfill industrial demand. When manufacturers attempt to acquire physical silver, premiums skyrocket, liquidity dries up, and operational plans face immediate disruption. The disconnect between paper markets and physical reality is growing, and with China's potential export restrictions, the gap threatens to explode. Industrial planning now requires a new level of strategic foresight. Companies must account for potential supply shocks, secure alternative sourcing, and develop contingency plans for every project dependent on silver. Engineers redesign circuits to use minimal amounts, factories stockpile months of refined metal, and investors watch the premiums on physical silver rise. Every decision, every design choice, now revolves around scarcity rather than innovation. This scarcity is shaping corporate culture. Engineers are learning to innovate within strict limitations. Research is directed toward practical optimization rather than speculative breakthroughs. Industrial hierarchies shift, favoring regions and organizations that have secure access to refined silver. The West, having outsourced most refining decades ago, finds itself structurally disadvantaged. Production costs increase. Timelines stretch. The ability to compete on technological innovation is constrained by material availability. Governments are scrambling, but policy frameworks lag behind reality. Trade agreements, import-export policies, and strategic stockpiling are reactive, often insufficient, and slow to address the concentrated power China holds over refining. Industrial conglomerates and sovereign wealth funds are quietly acquiring physical silver to secure continuity of operations. Private accumulation is creating a parallel market where access dictates who can operate at full capacity and who must delay or ration production. The financial markets are beginning to feel the tension. Futures contracts and paper pricing no longer reflect the operational reality. Industrial demand for physical silver drives premiums higher, creating volatility that is invisible to the public but absolute for companies dependent on uninterrupted supply. Factories experience idle time, delayed projects, and escalating costs, while investors witness sudden price surges, often without understanding the operational causes behind them. The Green Revolution is quietly being slowed. Solar installations, critical for reducing carbon emissions and achieving energy independence, are delayed. Electric vehicle production, meant to accelerate the transition to sustainable transportation, faces constant bottlenecks. Energy policies built on assumptions of material availability are being revised in real time as supply chains falter. Talent and innovation are migrating toward regions with secure access to refined silver. Engineers, scientists, and technologists gravitate to companies and countries where supply chains are robust. Knowledge and expertise follow material access. Innovation flows not necessarily where ideas are brightest, but where industrial inputs are guaranteed. Control over refined silver is quietly determining the distribution of technological power globally. This is not an abstract concern. It is operational, immediate, and strategic. Every idle line, every delayed shipment, every postponed solar project is a symptom of the same structural dependency. Nations, companies, and investors who fail to account for this will find themselves reacting to crises rather than shaping their own industrial future. The industrial siege imposed by silver scarcity is subtle but relentless. It dictates timelines, cost structures, and production capacity. Factories optimize not for growth but for continuity. Engineers innovate within limits, finding incremental efficiencies where breakthrough technologies might otherwise thrive. Market pricing no longer reflects abundance, but scarcity, and the invisible hand guiding supply is concentrated in one nation. Tesla, Apple, and the solar industry are not isolated cases. The crisis is systemic. Every advanced technology, every high-efficiency energy system, and every electrified vehicle is vulnerable to supply bottlenecks in silver refining. Operational risk has become strategic risk. Industrial resilience depends not only on engineering excellence, but on material security. Financial markets may attempt to signal abundance, but operational realities cannot be ignored. Every delivery delay, every idle factory, every missed energy target is a manifestation of concentrated control over a single, critical material. Silver is no longer just a commodity. It is a determinant of technological progress and industrial sovereignty. As the world races toward electrification and renewable energy, these constraints will become more pronounced. Demand will continue to rise. Supply may tighten further. Governments and companies must act with foresight, securing stockpiles, expanding refining capacity, and developing strategies to mitigate dependency. Industrial planning is no longer just about innovation, it is about access. The quiet power of silver dictates outcomes. Every electron conducted, every solar watt harvested, every electric vehicle powered relies on this critical metal. The narrative of limitless technological ambition is challenged by a harsh truth. Progress is constrained by the availability of materials, and silver is among the most decisive. This is the invisible siege shaping the future. Factories, supply chains, engineers, and policymakers all operate under the shadow of scarcity. The pace of innovation, the cost of production, and the distribution of industrial power are dictated by refined silver. Every strategic decision, every investment, every operational plan must acknowledge the quiet but absolute influence of this metal. The future is not written by ideas alone. It is written by access, control, and the strategic management of scarcity. Silver governs timelines, costs, and capacity for the modern industrial world. Tesla's EV lines, Apple's electronics, and the solar industry all converge on this invisible vulnerability. The industrial siege continues silently, but decisively, shaping technology, industry, and national power in ways that are largely unseen but profoundly consequential. As the global economy accelerates toward electrification and renewable energy, the industrial dependence on silver becomes impossible to ignore. Factories across the United States and Europe operate under the silent threat of supply disruption. Tesla's EV production lines pause intermittently, not because of technical failures, but because the high conductivity silver required for inverters, motors, and battery contacts is delayed. Apple faces similar constraints, with device production and assembly slowed by the scarcity of refined silver components. Solar panels, the backbone of the green revolution, are equally vulnerable. TOPCon cells, advanced photovoltaic technologies, require precise layers of silver for optimal performance. Any disruption in supply reduces efficiency, delays installations, and slows the transition to renewable energy. Governments may issue ambitious energy targets, but they are increasingly tempered by the realities of material dependency. Policy statements promising rapid deployment of solar farms and EV charging networks are undermined by the invisible bottleneck of refined silver. China's control over refined silver is not accidental. It is a strategic leverage point that has emerged from decades of concentrated industrial investment. Raw silver can be mined elsewhere, but only China possesses the chemical, metallurgical, and industrial infrastructure to refine it at the scale and purity demanded by modern applications. This concentration grants them silent control over global industry, from clean energy to electronics and even national security sectors that rely on high performance conductive materials. Financial markets attempt to mask this reality through paper contracts and futures. Trading COMEX silver contracts suggest abundance, but industrial buyers know the truth. Physical delivery is increasingly constrained, and premiums for actual refined silver are rising sharply. Stockpiles are being quietly accumulated by private investors, industrial conglomerates, and sovereign funds, creating a shadow market that operates outside public scrutiny. Those who control access to refined silver gain strategic leverage over competitors, nations, and entire industrial sectors. Every idle factory, every postponed project, and every delayed shipment is a visible symptom of this structural dependency. Operational risks have become strategic risks. Companies must allocate resources not just for innovation but for survival. Engineers are redesigning circuits to minimize silver usage. Managers are rationing materials across projects, and investors are recalibrating expectations for growth. This shift is not temporary, it is systemic, structural, and long-lasting. Western nations that have outsourced refining for decades face structural disadvantages. They depend on imports, creating vulnerability to geopolitical leverage and supply shocks. Industrial strategies must now prioritize securing material supply over expanding capacity or accelerating production. Companies that fail to adapt find themselves consistently behind, unable to meet timelines, unable to scale, and increasingly dependent on regions that control refined silver. Innovation itself is being reshaped. Engineers learn to work within limits, optimizing rather than pushing boundaries. Research focuses on incremental improvements instead of radical breakthroughs. Industrial culture evolves to value resilience over ambition. Talent migrates toward regions with secured supply chains, concentrating knowledge and expertise where access to refined silver is guaranteed. The result is a global redistribution of industrial capability, not based on innovation alone, but on access to a single strategic metal. The implications extend beyond industry. Energy independence, technological leadership, and national security are all intertwined with access to refined silver. Governments are forced to respond, often reactively, to the structural vulnerabilities that have emerged over decades of globalization. Trade policies, stockpiling strategies, and diplomatic negotiations are now conducted with the unspoken understanding that refined silver is a critical strategic resource. Those who control it control not only production but influence. Tesla, Apple, and the solar sector are the most visible indicators, but the crisis is systemic. Electric vehicles, advanced electronics, and renewable energy infrastructures all converge on the same dependency. Supply shocks reverberate across industries, creating cascading delays and cost escalations. Investors and policymakers may attempt to mitigate the risks, but operational realities cannot be ignored. The industrial world is being quietly reshaped by a metal once considered mundane. The invisible siege imposed by silver is absolute. It dictates production capacity, timelines, and costs. Factories optimize for survival rather than growth. Engineers innovate within constraints rather than pursuing breakthroughs. Market signals, decoupled from physical supply, fail to convey the full picture of scarcity. Governments scramble, policies lag behind, and industrial decision-making is driven by the realities of material access rather than technological ambition. Supply chain risk has become strategic risk. Every delay, every idle production line, and every postponed energy project reflects the concentration of refining power in China. Even as public discourse praises the rapid expansion of EVs and solar energy, the hidden dependency constrains progress. Premiums for physical silver rise. Industrial planning becomes dominated by access rather than capability. Stockpiles, both private and governmental, emerge as critical levers of power. The broader narrative is clear: technological innovation cannot outpace material scarcity. Every high-efficiency system, every electrified vehicle, every solar farm is vulnerable to disruptions in refined silver supply. Ambitions for rapid industrial and energy transition collide with the reality of concentration. Factories, governments, and investors must adapt to the new constraints, prioritizing survival, resilience, and strategic access over speed and expansion. This is not a temporary disruption, it is a structural shift in the foundations of modern industry. Control over refined silver now dictates timelines, costs, and operational capacity across multiple sectors. Industrial dependence is permanent, and the consequences are profound. Innovation follows access, not imagination. Talent, infrastructure, and capital gravitate toward regions with secure supply. Nations that fail to secure refined silver will face chronic delays, escalating costs, and reduced competitiveness. The industrial siege is ongoing, subtle yet absolute. Every operational decision, every investment allocation, every engineering redesign, and every production delay is shaped by silver scarcity. Factories optimize for continuity, engineers innovate within strict constraints, and markets struggle to reflect physical reality. Governments, often reactive rather than proactive, attempt to mitigate risk through trade agreements, stockpiles, and diplomacy. Yet the underlying leverage remains concentrated. As electrification expands and renewable energy adoption accelerates, these constraints will intensify. Demand for refined silver will rise, supply will remain concentrated, and premiums for physical metal will continue to climb. Industrial strategy must evolve to reflect these realities. Risk management becomes central, innovation becomes adaptive, and survival depends on access. Silver is no longer just a commodity, it is the axis around which modern industry rotates. Its scarcity dictates the pace of technological progress, the capacity of energy systems, and the competitiveness of nations. The invisible siege continues, shaping the trajectory of innovation, production, and power. Every decision, every delay, every project bears the mark of this quiet but absolute metal. The future will be defined not solely by ideas or ambition, but by the control, distribution, and strategic management of scarce industrial resources. Silver governs timelines, costs, and industrial sovereignty. Tesla's EV lines, Apple's electronics, and solar installations all depend on it. The silent siege shapes the industrial landscape, dictating what can be built, where, and when. Operational reality cannot be ignored. Industries operate under the shadow of scarcity, forced to adapt to the concentration of supply and the geopolitical leverage it creates. Engineers, policymakers, and investors must recognize that technological vision is constrained by material access. Factories optimize for resilience, research adapts to limitations, and industrial power consolidates around regions with secured silver supply. The story of silver is the story of modern industry. It is invisible, silent, yet decisive. It dictates the pace of innovation, the cost of production, and the distribution of industrial capability. The industrial siege continues, quietly shaping the future of technology, energy, and global power. Every strategic choice, every operational decision, and every industrial ambition is influenced by the availability and control of this unassuming but critical metal. The industrial world is fragile, and silver is at the heart of its vulnerability. It is a metal so small, so unassuming, yet it determines the pace of the most ambitious technological projects on Earth. Factories in the United States, Europe, and Asia depend on it for every high-efficiency circuit, every electric vehicle, every solar panel. Tesla's production lines, Apple's manufacturing operations, and global solar energy projects all converge on the same resource. Yet, the public remains largely unaware of the silent leverage China holds over these industries. China's dominance in refined silver production is not merely economic, it is strategic. Raw silver can be mined in many countries, but refining it to the purity and conductivity levels required for modern applications is concentrated almost entirely in Chinese facilities. This creates a choke point with profound implications. Any disruption, intentional or incidental, reverberates across global production lines. Factories pause. Projects stall. Delivery timelines slip. Costs rise. The green revolution, which promises energy independence and reduced carbon emissions, is not immune. TOPCon solar cells, which are the most advanced technology currently deployed, require precise layers of silver. There is no substitute that can match its performance at scale. Without a steady supply, solar installations are delayed, energy targets are missed, and governments are forced to revise plans for renewable energy expansion. The very transition to a cleaner, more sustainable energy future is constrained by a single metal.